In this short video, I want to walk through how to set up dragging behavior, specifically in the context of Florence visualizations. In your class material so far, the main types of interactions that you're already familiar with are basically clicking and the mouse over, mouse out, so basically hover functionality. In a very similar way, we can also set up dragging behavior. Drag here basically meaning if you use a mouse, you click, you move the mouse, and you let go again. The same with a mobile device, you touch down with your finger, you move your finger, and you lift up. This type of interaction is often used, and I think you're probably most familiar with in the context of maps, where if you want to pan a map, you do exactly that, right? You click the mouse, you move the mouse, and you lift the mouse button again. So how do you set something like that up in Florence? Just like, and I'm here on the Florence documentation page. Just like there are click and mouse over and mouse down um, event listeners, we have also implemented a drag event listener, which is basically a combination of all of these event listeners, but it makes it a little bit easier to kind of wire things up so you don't need to individually listen to a mouse down and then a mouse move, etc. But instead, you can just do on mouse drag. So how does that actually work? If we scroll down to the there we go, to the dragging section of the documentation, there's a very simple, but I think quite a powerful example here. What we're doing is ultimately we're creating this very simple visualization. It has, what is it, 1, 2, 3, 4, 5 black circles or black dots. And what we're seeing here, if we move one of them, the blue dot in the middle moves accordingly. And if you move a couple of these, what you start to see is that actually the blue dot always remains exactly in the middle. So it's kind of the centroid of those 5 black points. So how is it actually set up? If we look at the Svelte syntax here, quite familiar. We import the graphic section, the point, etc. We also want to do some linear scaling, so we import that as well. And then what we do here is we create 5 random points. So the X and the Y coordinates are generated randomly. And then we also here create that center point. So basically we map over all of the 5 X coordinates and then 5 Y coordinates, and we basically take the centroid or the middle point. And then if we look at the actual template syntax here, we draw a graphic 300 by 300 pixels. We set the scale X and the scale Y to 0 to 10. So that's basically our coordinate system. And then what we do here is we draw each of the 5 points. And then additionally, we draw one single point and we make that one blue. The other ones by default are black. So these 5 points within those each loops, those are the 5 black ones. And then we have a single blue one with a slightly smaller radius that's plotted here. Now, how does this work once we move this? Basically, all we do here is we add a single listener, event listener, on the 5 black points. And then whenever that listener is being fired, we take the event that's being fired and we give that to this drag function together with the index of the point. So we know basically which point should we update. Now, what is actually happening inside of this drag function? We can see here that the drag function will actually get from that entire event object only 2 keys, 2 specific keys, the drag type key and the local coordinates key. The drag type key actually contains the type of interaction that's happening at that very moment. As I told you before, you have kind of the start of the drag, so that's the mouse down, then you have the mouse move, and then you have the mouse up. So those correspond to start, drag, and end. And then we also have the second key, the local coordinates, and that's actually the coordinates of the current mark that's being activated. in the local coordinate space. So in this case, that goes from 0 to 10. Um, what do? A couple of things. When we start dragging, we set this block reindexing to true. I will talk about that in a minute. Then, and this is the main thing here, when we are dragging, what we basically do is we set the coordinates of the point at this index, so that's the actual point that we're currently dragging, to the coordinates of the mouse. So that will actually update the point's position to whatever the mouse is currently on. So that's really the meat of the matter. And then what we can see here, whenever one of our points is being updated, our center point will update accordingly because we've made that definition of the center point reactive. So that is what makes everything actually move. So the black point is now moving because I'm updating it continuously, and the blue point is moving alongside because I have made my center definition reactive. So whenever something is happening inside of those points, it will detect it and it will update the center point accordingly. So there's this one final bit of kind of maybe that looks a little bit weird. That's this block reindexing variable that we have initialized here. When we start dragging, we set it to true. When we finish dragging, we set it to false. And you can actually see here that we give that variable as a property to the section here. Now, what does that do? Basically, it does exactly what it says in the name. It actually blocks the indexing from happening. Now, what is this indexing? It's basically to do this type of detection. So basically, whenever we move the mouse or we click the mouse, to know which are the marks underlying your mouse at that point in time, what's happening in the background is Florence constructs a spatial index, so it can do those types of kind of lookups much faster. But if we move a point, what it will have to do is it will have to rebuild that spatial index because there's a new point active at this very moment in time. That's relatively expensive. So if we do that continuously on every single little move, you will notice kind of a slightly slower kind of user experience. So basically what we do is we stop that indexing processing from happening at the start of the dragging, and we start it again when we're done. So that takes care of, we don't really need to be continuously indexing during the drag. So that takes care of that little bit of a performance issue. Now, with 5 points, this is a little bit less important, but if you had hundreds or even thousands of points, then you definitely want to make sure that you're not continuously re-indexing all of the points when you're doing something that's updating so often. Every time you move one pixel, this will fire. So that's why that property is there.